Now, what is a query ordered before SQL, structured query language? What is that? It's actually just a way, maybe you have a library and you have a librarian taking care of it. How are you or your web application going to talk to that librarian? Librarian doesn't know English. Librarian only knows a query language, which is a structured query language. Okay, so that's how you are going to use SQL to query your database. Now let's do a case study. If you have an e-commerce website, your customer should be able to register and log in. Your customer should be able to view different products. Your products belong to different brands, categories, and segments. Customers should be able to filter products based on them. Your customer should be able to add products to wish list and cart. Now, can you see there are so many nouns over here, and all of these nouns will become entities in our relational database. I'm going to actually show you how we are going to design this database for an e-commerce system, okay? Then your customer should also be able to check out from your cart and pay using a payment service. The customer should be able to check all of his or her orders and track each of them. Also, your customer should be able to give reviews to his or her bought items. There's also a seller, right? Seller should be able to register and log in. Seller should be able to add products to list for selling. Seller should be able to view all current orders to fulfill them. So what we actually design it is in the form of entity relationship diagram if you want to use a relational database. So you would have a customer, you would have a shopping portal, and the customer belongs to the shopping portal. That is the relationship. So these are entities, this is a relationship, and that's why we have entity relationship diagram. We also have so many attributes of customer. We would want to definitely store the username, the name and ID, password, email, etc. of the customer and the address for shipping. Also, all of these different requirements which we had, we would have, a very complicated ER diagram, which I have just split for ease. So your online shopping portal would also have segments and categories for each product. Each product has a category and each category has a segment, and product also has a brand. And I've just put some minimum attributes: segment ID, segment name, category ID, category name, brand ID, and brand name. Also, your customer would do a payment for his or her cart, and the payment would have information and the time at which the payment is done. That is not a part of payment. That is also not a part of customer. That is the part of the relation. Okay. So customer would do the payment at that particular timestamp. That becomes an attribute of the relation. And these double lines which you see over here, this is total participation, and single line is partial participation, meaning every customer definitely belongs to the portal. It's not that any customer doesn't belong to the portal. Obviously, the customer belongs to the portal, right? Now, you could have all of this information, okay? So everything I have put down into one, and product also has all of these information. Now, what you do is you actually take that entity relationship diagram and now you design all these tables, okay? So we had our product, which is belonging to a brand. So what product will have? Product will definitely have a product ID, but product will also have a brand ID because product belongs to that brand, right? It will also have a category ID because it belongs to the category. It would also have a segment ID because it belongs to the segment. Your cart would have, all these items, cart ID and the product ID as well. And the customer ID would be present in your payment as well, because otherwise, how are you going to map your payment to the customer? So this is the part of designing which we do, or which a database engineer does. Okay, so it could be, very, very complicated. And we could have, cardinality, meaning that there could be a category which is a subcategory. So how many subcategories are possible for each category? There could be n number of subcategories, right? So n is to 1. And, this is the way we actually, keep designing our database. So what you do is you determine the purpose of your database, then you choose the type of database, you organize the information required, meaning you model the database, okay, in terms of entity relationship diagram or any other diagram. And then if you have a DBMS or relational database management system, you understand what are the entities, relations, the cardinality, the participation, and then you actually divide the information into tables. Or if you have a document-based database, then you would definitely, divide your information into collections and documents. You would then specify the identified keys, as I said, customer ID, etc. And then the last thing which you do is, which I have not showed you over here, is you would refine your design. You would do some sort of a normalization. What is normalization? Basically, you want all these asset properties and no, problems with your database. So you would refine your design, okay? And then voila, your database design is complete. After refining, your database is going to be very, very efficient. Now let's actually look into a little more about NoSQL databases. because I've taken the case study for relational database. So, why to do this, unfairness? If you want document-based databases, I showed you an instance of MongoDB. If you want column-based databases, that is an example of Cassandra. So what are column-based databases, first of all? It is a midway between relational and document-based databases. So it actually has a fixed schema, but it generally does not, guarantee asset properties. So that's the only difference. And this is again used if you have heavy writes requirements. So if, people are keeping on writing to your database again and again, let's say, streaming application in which, people are constantly viewing songs. So that adds to the history, and constantly liking or, swiping away songs. For that, you would maybe, use Cassandra. The next database is search database. You might have heard at least about Elasticsearch or any search databases. Now, Google search, or in fact, any website in today's world has a search option, right? So what happens is that we, just like we have book, okay, the book would have an index. So if you want to go to some particular topic, you would simply look at the topic on the index and then go to that page number, right? So similarly, these search databases, what they do is they index all of your data, and they have really advanced indexing systems such that if you simply search, let's say you search on LinkedIn about anybody, okay? Now, LinkedIn has billions of users registered, okay? It looks at one by one user, if that name matches, approximate matches, etc. You are going to sleep, okay? But LinkedIn actually gives it to you in a fraction of a second. How is that possible? That is only possible if you use a specialized search database like Elasticsearch, which is actually indexing all of your data. And remember that the data which is indexed is, not in the primary database, it is in the search database, okay? So maybe, somebody else comes up in this time and, registers. Your search database is going to take a little bit time to reflect that. So search databases, again, extremely important for you to know if you want to study databases and work as a database engineer. Then lastly, we have key value stores. As I said, that it would be used as a cache. Okay, so you have your application over here, and you have, let's say, your database, let's say your MongoDB database over here. Now your application interacts with the MongoDB database, but MongoDB database is a little slow. Okay, what happens is that you could introduce a caching layer over here. This is a key value store. What you would do is, first you would check if your database is in cache. If it is, then cool, just read it. If it is not in cache, then you get it from the database, you save it to cache, and then you read it. So what happens is that we first request the caching layer, and thereby we reduce the load on the DB server. So for everything, you don't want to go to the DB server on MongoDB. So that's the next advantage, For everything, your DB server is not loaded, because maybe you really need some frequently, searched items over here. So, you could simply search it from here and query it from here instead of querying it again and again from the database. So this reduces load, and this is actually very good for short-term temporary data, okay? If you want to remember something of the user, let's say for 10 seconds, just store it in the cache. Don't worry the database with such, short problems. Like for any issues, you would go to your support engineer. You would not, keep going to the instructor, Only if you do not find any problem solved with support engineer, you would, request your instructor to, teach it again. Something of that sort. Now, we saw so much about making databases fast, etc. That comes under database scaling. Scaling means scale your web application, scale your database for millions of users. So what we just saw is that your database is there, which is dealing with your application and giving the result to the user. Instead of that, just add a caching over here. So first your application, queries the cache, and if not, it is going to query the database. But even for the main database, it's not that one database we can be rest assured, and sometime maybe earthquake happens and you lose your entire user's data and your company is suddenly closed. That should not happen, right? So there are some ways in which you want to secure your data, plus you want again to have very consistently correct data. So for that, what we do is we may do some sort of partitioning, meaning, like, for example, you have employees data, okay, and you have employee ID, employee name, picture, and signature, okay. So that is in your 4 columns, okay. But you realize that, generally you do not need picture and signature image. You mostly want to query over employee ID and employee name only, okay. So what you can do is actually you can slice your database from middle, and then you can keep on querying over here. So this huge data is never touched, and that makes it very, very fast. Okay. So you could do this type of a vertical partitioning, or that, maybe if I want to search from 1 to 100 employee ID, I would go to this particular partition. If I want to, see from 200 to 400, I would go to this particular partition, that way. So you could also actually do a horizontal partitioning and thereby just minimize the number of rows you have to query for each information. Okay. That is also possible. Then you would do something known as replication. As I said, that the information should not be only at one place. It should be replicated to other places as well, just for security. For example, your master database, suddenly stops due to some reason. Then you at least have your other databases, which are known as slave databases, which are actually going to give you the information. So generally what we do is we keep on, in fact, writing only to the master database, but a replication of the master database is present in the slave databases, and we keep on reading. So mostly you realize that, users generally read data. Okay. They write less data. I don't think so anybody is there who would post more on Facebook than consume other people's post on Facebook, right? For reading, you could, use multiple instances of the database, and just for writing, you would have master. So now one question you might be coming in your mind, right? If you keep writing to the master, in, let's say even 10 seconds or 10 minutes, your slave databases will become obsolete. Your slave databases would not have the current copy of your master database, right? That's absolutely possible, and that's absolutely fine. Why? Because we give approximate, figure. Let's say somebody has followers, 3 million followers, okay? And you just give 3.1 million to the users. You don't say 30 lakh, 1,243. No, you don't give that accurate information. So for reading, it's good. And once your master data actually, updates with the current new number of followers, it may increase to 3.15 or 3.18. It still remains 3.1 until you update it to 3.2 million followers. Okay. The last thing which you would do is, after you have replicated and, you have used your slave for faster reads and for good consistency, etc. Then lastly, if still your database is so huge that you cannot keep it in one machine, you would have multiple instances in which you would have divided your database. So this is actually very similar to partitioning, but you just have put it in different databases. And again, you would have databases on cloud. Finally, you would put your database on cloud. So your cloud, engine is actually taking care of all of this for you. Now, is it really worth studying all of this? Remember, working with data requires knowledge of databases and SQL. Okay. And the number of jobs related to data are huge. It can vary from database administrator to data analyst to big data engineers and much more. And remember, SQL as a language isn't going anywhere. It's going to be over here at least for 10 years now. Okay. So, close your eyes and learn SQL, become a database engineer if you want to be good in your computer science field. Also, you need to know all of this if you want to become even a full stack engineer or a backend engineer. Okay. And as for average salaries of SQL engineers, you would say, let's say in India, it's written 4,40,000 per year, or 4,73,000 per year in 2020, or in US, it would be $96,000 a year approximately. So pretty decent and, in fact, very good salaries based on the very easy language as SQL is. Now, what are the typical job roles in entry level you would see? You may be a database engineer or a backend engineer or a full stack engineer. All of these require knowledge of SQL and databases. You may be SQL developer, member of technical staff, or a software development engineer one, or an IT engineer one. If you, go to a senior level, you would realize that the salaries would definitely, keep increasing. So it says 6,83,000 for senior level. So now for senior level, you would have a database administrator job, architect job, analyst job, technical lead. Now this is much, much more senior level. Okay. A big data engineer, product manager, program manager, etc., or software development engineer 3, IT engineer 3. Also, in top management, when you reach, you may become a manager, people manager, a vice president, chief technology officer, or a CEO. So now, how do you prepare for this? Okay, you could go directly to the official documentation. You want to learn MySQL? Go to the official documentation of MySQL, read about it, learn SQL, and then start using it. But it's a little tough. It's boring also. So why not just take help of online courses or tutorials or articles. Skill-Lync also provides, good number of courses. You could then, once you understand how it works and all, the most important thing without which you should never, start applying for jobs is practical projects. Do some practical projects, build your portfolio, maybe on GitHub or anywhere else, and show it to the recruiters. Okay. You should practice design and interview questions of databases. Also, you may try to get some certifications, etc. That may also help, but you should definitely have the knowledge of it. So lastly, I just want to, give some sort of a motivation for you, just in case everything is looking very difficult for you or, very, overwhelming. Then remember, data is very important. You can have data without information, but you can never have information without data. Okay. So learning to deal with data, building a good database system for a web application for people to use, customers to use is extremely important. Okay. You should get so good that they cannot ignore you. Okay. Do not think that, okay, I might, study a little bit and, maybe I would be good. No, you should be obsessive about it. So either you be obsessed about it or you just be average. Choice is yours. If you are obsessed about it, if you have a lot of knowledge, you can design a great database system. You can design a great web applications. You are definitely going to get hired. Okay. And don't worry about COVID-19. In the IT industry, it has not really hit that bad. Okay. So do not worry about that. Definitely be obsessed about your learning. Definitely be obsessed about the new things. In fact, the good thing about, whatever we have discussed is I have discussed the latest things. Okay. Generally, if you search for database management ideas, you would stick to only DBMS or NoSQL, but you would not, go into advanced topics of how you would scale your database, how you would use caching layers, how you would use search databases, etc. So remember, study everything about the ecosystem, and that's how you would be, the best amongst all. And then lastly, how do you do that? I mean, it's so overwhelming, right? The only way to do that is to do that. Just go do it. Begin from somewhere. Begin from, basic things, basic tutorials, okay, basic courses, and then, start building yourself up. And the only way to do great work is to love what you do, okay? Understand how this evolution of database systems, right from file systems, okay, put your entire data into files. From there, we actually move to such sophisticated mechanisms. And how is it really helping? It is helping in securing you in your Uber ride. Okay. It is constantly updating the database with your, location and publishing it on your application. Okay. It is a matter of security. It is a matter of your data. It is a matter of, recording history of your bank applications. Okay. It's a matter of extreme importance if you see, and that's where, you will be, completely awestruck with how, the companies are, dealing with their data, how your project on GitHub is secure even after 10 years, how your emails are secure and, how your emails are taking care of your security of your data, so that you do not lose your data, you do not use your credentials, etc. So if you love all of this, if you realize that, how important this is for people's lives and, how it has changed people's life, you would, definitely love it and you would definitely do great work in it. So I wish you all the best in your journey.